Welcome to the fifth and final video covering straight line theory for higher maths. This fifth video is going to focus on intersecting lines, obviously intersecting lines within the context of the new material we've learned on straight line, whilst also using material that you would have learned previously in National 5. Learning intentions. I want you to be able to find the point of contact for intersecting lines using various different scenarios. So, what do we mean by intersecting lines? Hopefully your knowledge from National 5 isn't that distant that you've totally forgotten. Intersecting lines are where two lines, two or more, so in some scenarios there might be more than two, but generally it'll be two we deal with, intersect. So it's lines that cross, and they will have a point of contact, and that'll be one coordinate. And since they're straight lines, therefore they can't deviate, there'll only ever be one point of contact for two straight lines. What method have we learnt before to find the coordinates at the point of intersection? If you were in my class, this should not be new to you. As I stressed at the time, this is a skill you're going to be using further down the line within the course and higher and beyond. It's simultaneous equations. From simultaneous equations, this will always be the method you use. Now, there are three sub-methods within the topic of simultaneous equations that you learnt in National 5. There was the graphical. Graphical was purely a conceptual method, a way for you to kind of understand visually what was going on, but in a mathematical context, it's not really that useful. So we really won't be using that. The other two methods were the elimination and substitution. If you're in my class for National 5, I stressed to you at the time that the elimination method was popular at National 5, but in reality, the substitution method as a context, as a concept, it is more useful because we're going to use it in other contexts and other chapters further on within the higher course. So understanding it was more important. So 9 times out of 10, I will prefer to go down the substitution method, but for straight line questions, certainly feel free to use the elimination if you prefer. But as I stressed before, we are going to use the substitution method again later in the course with other types of equations, quadratics, polynomials, trig, circle. So getting used to that method is a must. So I'd advise you do it at this point. To be able to use simultaneous equations, you do need the two equations for this to work. So, first example, nice bog standard. You could have been asked this sort of question at National 5. It's saying lines A and B and C, D intersect. The coordinates A, B, C, and D are -3, -4, -1, 4, -3, 2, and 0, -4 respectively. Determine the point of intersection. Well, to find where lines A, B, and CD intersect, we actually need the equations of line A, B, and line CD. So to find that equation, we've got to use our skills about gradient, yield, faithful to find it. So I would advise if a question in the likely event in the exam doesn't have a diagram, add it. There are times they might do that, so add your own wee diagram. It's a sketch. Do not take your ages doing it. Just lightly sketch, roughly plotted coordinates, and that will give you an idea of where the coordinates should lie, and therefore a way of checking that your answer. If you're given a diagram, always compare your answer to the diagram and make sure the solution you have matches the diagram you've been given. So finding the gradient of AB, just use the gradient formula as normal. Watch out for double negatives and negative numbers becoming more negative or becoming positive, things like that. So simplify, simple form, we've got a gradient of 4, which from my diagram, AB does look quite steep, so I'm quite happy with that. So using AB with the coordinate for either A or B, doesn't matter which, with yield faithful, gives us an equation of y equals 4x plus 8. Finding the gradient of CD, using formula again, just take care. It's -2, it fits the diagram, it slopes down the way, and it looks relatively steep, so I'm quite comfortable with -2 being correct. Using -2 with one of the two coordinates for C and D, subbing it yield faithful gives us an equation of y equals -2x minus 4, which fits. You can see it would cross the y-intercept in the negative, so I'm happy again that I found the correct equation. We have been asked for the point of intersection. We have now two equations, so we can use simultaneous equations. Both equations are in the y equals form, so I would use the substitution method to find the point of intersection. Because remember, at the point of intersection, YAB will equal YCD. That's the concept at one point, and by equating them, the mathematics, the algebra, will give the answer to the question of when does YAB equal YCD, and it'll give the x coordinates. So doing that, manipulating. So again, all those skills that you were mentioned in first and second year, they are repeated again and again and used again and again. So all these math skills you learn are actually a lot of the time just a skill you'll use in a tougher context further down the line, the further you study within the maths course. Rearranging for x, you've got an x equals minus 2. If x equals minus 2 and y equals 4x plus 8, sub it in. You could have used the other equation. I don't mind what you use. We get a y coordinate of 0. Point of intersection minus 2, 0. And if you recall from the diagram, it looked like it lay on the x-axis, so therefore y coordinate 0, and it was definitely in the negative coordinates for x. So I'm quite comfortable I found the correct coordinate minus 2, 0. Moving on to exam level, a higher type of question. Here's one to try. Key concept to understand with this type of question is these are very popular, and a lot of times when they're asked, they're worth quite a considerable number of marks. You know, this example here I've picked deliberately because there's 9 marks available. That's a lot. You know, you're talking, what was it, between 5 to 10% of your exam result could rely on a big, massive straight line, special, you know, what was it, lines and triangles question. So getting good and strong at your understanding of straight line will have other benefits, but more importantly, it will have benefit in a directly related question. So I can't stress you enough, this is a big topic and it's very likely to appear in your exam. It's very likely to be worth a good number of marks. So part A, find the equation of the median BD. The important thing here is be on the lookout for triggers and also look at the marks. 3 marks says quite a straightforward question, but there's a wee bit of work involved. The second thing I look for, I see the word median. Median should trigger special lines and triangle. A median is a line that goes from the vertex to the opposite side and it crosses the opposite side or touches the opposite side at the midpoint. So we need to find the midpoint between A and C if it's the equation of the median BD. So identifying point D. So we take the coordinate A, we take the coordinate C. You're free to do either method. On this occasion, I've chosen to use the midpoint formula. You don't have to. You get no credit for the formula, just get credit for finding the point D, and that'll be 1 mark. Sub in the coordinates, 3, 5. I'm happy. A, it's whole numbers. Sometimes it won't be whole numbers, but generally, this sort of scenario, a nice whole number question, and it fits the diagram. It does look, it goes up more point D than it goes along. So I'm happy that 3, 5 is correct. Step 2, you've been asked to find the equation, the median. To find the equation, we need a gradient. So we go and find the gradient of the median using B and D, because we now have coordinate B, we have coordinate D. So again, step by step, you do something that then allows you to do something else. So using both in the, gradient formula, we get a gradient of 2. I'm happy with that. It's a positive gradient. It's sloping upwards. Last but not least, step 3. For step 3, we've been asked to find the equation, so we use yield faithful with everything else that we found. So we use it with a coordinate. Now you're free to either use coordinate B or coordinate D that we found. I'm going to stick with B purely because I was given it to begin with, so I know it's 100% correct. So in doing so, I sub it into the equation, work through my working, and you should have got an equation of y equals 2x minus 1, which fits. It should have a y-intercept that's negative. It should have a positive gradient, so I'm happy that I found the correct equation. Part B, find the equation of the altitude AE. Again, 3 marks, so it says there's a wee bit of working, but should be quite straightforward. So I need to find the equation of the altitude. Altitude is the trigger phrase here. That should trigger, once again, thoughts about special lines and triangles. An altitude is a line, okay, that is perpendicular to the side of the triangle it touches. So here, our altitude AE is perpendicular to BC. If we know coordinates for B and C, that means we can find the gradient BC, which will then allow us, by using perpendicular gradient, another skill we iterated and recapped in this part of the course, to find the gradient of AE. So use the coordinates BC, find BC by subbing the formula, watch out for double negatives, we get a gradient of 1/3. Again, check it, 1/3 fits the diagram. It looks like it's quite a gentle positive slope, 1/3 is quite a gentle positive gradient. Since MBC is perpendicular to MAE, because they told us it was an altitude, we can use the M1 times M2 equals minus 1 to show that MAE must equal minus 3. Again, you don't have to show the working of how minus 3 comes about. As long as you make your statement, you can just simply flip 1/3, so it becomes 3/1 and change the sign, so it becomes minus 3. Using yield faithful again, we find the altitude of the equation with the coordinate for A, which we know is minus 112. We don't know E, and you won't work out E in this, so you are limited to be using minus 112 as your coordinate. Sub it in, and we get a y equals minus 3x plus 9. I'm happy with that. It's got a positive y-intercept, which fits the diagram. it's quite a steep downward slope. So everything, in my eyes, kind of makes sense in this diagram. Part C, it's asking you to find the coordinates of the point of intersection of BD and AE. These questions are popular. You do some work about an altitude, possibly a perpendicular bisector, a median, and then the last part of the question asks for the point of intersection. I'm not guaranteeing a question like that because they mix it up from year to year, but these type of questions have been popular where they make you do some form of intersection work as part of your final answer. So we use the substitution method of simultaneous equations to find the point of intersection lines BD and AE because we've worked out the equations in that form. If you want to rearrange them and use elimination method, feel free. But I stressed you need to be able to do the substitution method, so don't avoid it. Learn how to do it. You're doing higher maths, you need to be able to do this. So at the point of intersection, they equate each other, so equate them together, rearrange for x, as we've shown before, and we get an x coordinate of 2. That fits the diagram. It should be a positive value of x, therefore x equals 2 seems to fit. Sub x equals 2 in either equation, you feel free to pick whatever one, and we get a y coordinate of 3 again. It does look the y coordinate slightly higher, slightly bigger, than the x, and it should be positive, so therefore I'm happy that the point of intersection is 2, 3. So always use the diagrams you're given as a guide to make sure your answers are correct. Because trust me, when you're doing this amount of work over question after question, it is very easy to make a mistake, very easy. But if you use your diagram, you can prevent it. Third example to try. This was taken from the 2001 higher, paper 2, question 7. Again, when you start a question, I ask you to read A, B, and C. Always look at what the number of marks, 1, 4, 1, because that's a guide on how you're going to get into this question. Now, part A, write down the equation of L1, the perpendicular bisector of AB. There's two key words, two kind of key phrases that you need to pay attention to here. First and foremost, perpendicular bisector, right? You need to know what that means. That's taken from the special lines in triangles or lines in this occasion, because it's a perpendicular bisector. And understand what that means. It means it crosses at the midpoint of the other line, and it does so at right angles to it. The other key thing here is usually a question like that will be worth 3 marks, around the 3 marks, maybe 2, 3, depends on what year they did it and how the SQA are thinking, in terms of their thinking within that kind of particular topic. But it's usually worth more than a mark. So the 1 mark perpendicular bisector might have you scratching your head, but a key phrase here is the one they've written: write down. If they say write down, that usually is their way of telling you this should be something that you should be able to find without lots of working. You should be able to just look at something, process it, and write the answer down. So they're telling you that there's something in here that's going to be a giveaway and make this question easier than it appears at first. And what hopefully it is, if you look at that diagram, line AB is horizontal. It doesn't change its y coordinate. Therefore, we have a horizontal line for AB. And if we're looking for the perpendicular bisector of it, that means if it's horizontal, the perpendicular bisector will be vertical. That means it will have an equation of the form x equals, no y equals, none of that. It'll just be x equals, the x coordinate's always up. And since it's a perpendicular bisector, it always crosses at the midpoint. Therefore, we will be an equation of the x coordinate of the midpoint of AB. So we just need to find the midpoint. Again, you don't get any credit for the working, so I would work it out in my head here. The midpoint between 2 and 12, well, there's a difference of 10. So if we add 5 to 2, we get, x coordinate of 7. So therefore, the equation of the perpendicular bisector is x equals 7 because it's vertical. So therefore, that's why it was only worth 1 mark. Now, part B, find the equation of L2, the perpendicular bisector of AC. This is where it's different. This one has given us 4 marks. That suggests there's going to be a good bit of working, and this is going to be more like the traditional perpendicular bisector question. So, to find a perpendicular bisector, it crosses at the midpoint and it's at right angles. So we need to find the midpoint of AC, and we need to find the gradient of AC to be able to use perpendicular gradients to find the perpendicular bisectors. So find the gradient of AC. Use the 2 coordinates given. Watch out, 2/3. 2/3 fits the diagram. Looks like a relatively gentle positive slope. So I'm quite happy. Using perp lines, m1 times m2 equals -1, I can say that the perpendicular bisector's gradient is therefore the fraction flipped change sign of -3/2, which if I added to this diagram, that would fit. Midpoint of AC, again, you don't get any credit for how you find midpoint, so feel free to use either the midpoint formula or just kind of process it in your head using the coordinates given. I can find that halfway between 2 and 8 is 5. and halfway between 2 and 6 for coordinates A and C, the y coordinates must be 4. So therefore the midpoint of AC is the coordinate 5, 4. Using ye old faithful, because we now have a gradient and we now have a point of intersection, we can find the equation of the perpendicular bisector being 2y equals minus 3x plus 23. You'll notice I've chosen to go down the route of not making it y equals, because I already know that if I'm going to use y equals using the equation part A, equation part A is not the normal form y equals, so I didn't have to do it. But if you want to, feel free, but I just want to avoid using, fractions in this question, but that doesn't always work, so it's very question dependent. Now, the point of intersection of lines L1 and L2, we just need to equate them. It's only worth 1 mark, and the reason it's only worth 1 mark is one of the equations is just a number, so it's just going to be a case of subbing in. We know the x-coordinate of the point of intersection has to be 7, because perpendicular bisector line L1 will never deviate from an x-coordinate of 7, so therefore it has to be that. So we already know the x-coordinate of the point of intersection, we need to find the y. So we sub that in, do some rearrangement work to find y, and we get a y coordinate of 1, so therefore we have a point of intersection at 7, 1, and if I was to add to the diagram, that would fit. It would fit that the point does look like it's quite a long, quite a bit along the x-axis, but only slightly up there. Last but not least, I don't actually have a year for this one. I think this is one of the new ones. But if not, it's still a good question, because again, I've picked them because it's subtle variations of each one in order to kind of test your understanding of all branches within the straight line theorem. So, part A. AB is a line parallel to the line with equation y plus 3x equals 25. A is coordinates minus 1, 10. Find the equation of AB. It's only worth a mark. That suggests there's either little working, or the working you have to do is not considered at a high enough level that it's worth lots of marks. In this equation, the word parallel is key. I've thrown it in. We've learned about parallel. If a line is parallel to another one, it means they share the same gradient. Therefore, to find the gradient of this equation AB, we need to find the gradient of y plus 3x equals 25. That will involve rearrangement and simply reading the gradient. I think here they don't give you any credit straight directly for rearrangement or finding the gradient here, because we've then got to use the gradient to sub into the equation and find that it should be y equals minus 3x plus 7. So only 1 mark for a couple of lines of working. So there are scenarios where you will have to do working, but the working will be very simplistic, or it will be very orientated as a National 5 bit of working. Therefore, they're not going to give you a lot of credit higher. With that equation, we're asked, therefore, if 3y equals x plus 11 is a perpendicular bisector of AB, determine the coordinates of B. And this question is slightly different. We're not being asked to find the point of intersection per se. We've been asked to find the coordinates of B, which is just a point on the equation of line AB. To be able to do that, we do know the equation of AB, and we do know the equation of its perpendicular bisector. That would allow us, using intersection equations, to find the intersecting point. That intersecting point will lie halfway between A and B. If you know point A and you know the point halfway between, we can use stepping out to find B. So this one is worth 5 marks because we've got to find the point of intersection, but it's actually not what was asked for. It's going to be something we use to find the coordinate B. So part B, equate the two equations together and find the point of intersection. To do that, I would prefer to put them in y equals form, so I rearrange and get it in y equals form, equate the two of them. Again, this one's involved fractions. Feel free, both the fractions in the right-hand side are the same, so we could times out by 3 and remove any fractions from the questions. I would advise you to do that. You don't have to. Anything that makes your life easier, dealing with whole numbers is generally easier, less prone to error, is better. Rearrangement, and again, x-coordinate. Generally speaking, now this is just a general rule of thumb, nothing's perfect. If after doing working you get a nice whole number answer, there's a strong likelihood that's correct, because usually mistakes will lead to fractional answers. So I'm not saying fractional answers are wrong, but if you get a whole number answer, there's a good chance everything you've done so far is correct. It's not guaranteed, nothing's guaranteed with maths, but the rule of thumb is that means it's correct. Using that coordinate in either of the equations, you find that the y coordinate is 4, therefore the midpoint of line AB is 1, 4. So we know that the coordinate A is minus 1, 10. We know the midpoint is 1, 4. Well, we need to use stepping out, i.e. how far along the x did they go from A to the midpoint, and use that again to go from the midpoint to B. We do the same for the y. So for x, we started at coordinate -1, we moved to a midpoint coordinate, x coordinate of 1. Therefore, that is a jump of +2. So we jump another +2 because it's the midpoint, the same jump's got to take place along the x. And we get, what was it, x coordinate of 3 for point B. Doing the same for y. We start at 10, we drop 6 to 4. That means we need to drop another 6 to get to B's coordinate for the symmetry of it being the midpoint to be true. And we do that and we get a y coordinate -2. Therefore, B, the coordinates of B are 3, -2. That concludes video 5 of the straight line. That concludes straight line theory. Obviously, there will be more to do with straight line as we work through the different topics and new topics at higher. So again, I cannot stress getting a strong understanding of all the concepts taught within the 5 videos is very important.